Hi students, and welcome to Preliminary Chemistry and the final video in the Chemical Earth series. The last couple of videos we've been looking at the relationship between the structure of different solids and their chemical properties. And so this is the last of those, and that's a specific look at metals and metallic arrays. So the important thing when we're looking at metals is to try and understand what is happening at the solid state. So in the solid state, we have a number of different metallic ions. And each of these metallic ions, let's say they are sodium, for example, all have a very small number of electrons in their valence shell. So for sodium, that would actually be 1 electron. And these electrons are fairly weakly held. We know that sodium readily loses that electron when it undergoes chemical reactions. And in its metallic form, these electrons are free electrons or delocalized. And delocalized just means that they're free to move from one atom to another. And it's this freedom of movement as the electrons are moving around the metallic array that creates metallic bonds and holds this metallic structure together. As a consequence of that, there are a few very important properties of metals that we can explain on the basis of this arrangement. So firstly, the metallic lattice consists of a number of positive metal ions, or cations is the way we refer to positive ions. Now the overall structure is still neutral. That is, no electrons have actually been gained or lost, but they are free to move. They've been delocalized. They're now electrons that are not being directly held by their parent atom, but they are moving freely between different atoms within the lattice, within the crystal structure. So these delocalized electrons have all come from the valence shells of the metallic lattice, and the chemical bond that exists between the atoms, the metallic atoms, metal ion, and free electron is called a metallic bond. And it's just an electrostatic attraction between those free electrons and each of the individual ions that make up the metallic lattice. This electrostatic attraction causes stability, and not only does it create stability, but it ensures that we have very high melting and boiling points for most of our metals as a consequence of this strong bond that's between each of these individual ions and the free electrons. So metallic bonds form between metal ions and free electrons within the crystal lattice. An understanding of this helps us to explain some of these very important properties of metals. The high melting point and boiling point is a consequence of the chemical bond between the individual metallic ions and the electrons, and that chemical bond is called a metallic bond. And because it's equal in all directions, there's no weak spots within the crystal, and so therefore it requires quite a large amount of energy to move those apart from one another so they can flow as they will in either a liquid or a gas. The fact that there are free electrons or delocalized electrons explains why metals are such good conductors of both electricity and also of heat, so electricity and thermal conductivity. Because if you put a potential difference between the two ends of the metal, then the electrons will all start to drift towards the positive terminal, and that will give you a flow of charge. All of this will be moving in the same direction, and that's a current. Likewise, heat energy is going to give the particles more kinetic energy, and therefore they will move more quickly, bump into other electrons, and push them as well. So it's not just electrical potential difference that can create a flow of charge, it's also heat that can create those moving electrons and transmit that energy from one end of the metal to the other. The high density is a result of close packing, and the metallic ions can be very close to one another because of that sea of electrons that is holding them together and keeping the integrity of the structure. The way that the light bounces off the ions the surface of the metal gives it its lustrous or shiny appearance, and it's also malleable and ductile, and that's because if we were to look at what happens when we have the metallic ions all sitting in their little sea of electrons, and then we were to hit them with a hammer in some place, we might displace those ions, but the electrons are still going to flow around them, maintain the integrity and the bonding between the electrons and the ions, and so hence the shape will be maintained. And that means that we can both shape our metals and we can also draw them into thin wires. Now you've had a look at ionic lattices, covalent lattices, metallic lattices, and also covalent molecular. You should now be able to draw up a table something like this to summarize the different properties, and from these properties you should be able to explain them in terms of the structure of each of these different types of lattices or arrays. So I suggest that this table would be a good study tool or a summary tool for you to use in order to try and remember what's going on with each of these different types of solid structures and how the structures relate to the properties. Thanks for watching.